Hello everybody, we're continuing on page number 19, and if you recall last time we left off on factoring by grouping. Remember, that's when you have four terms. So we did this example in class. We skipped the justification, and you would have done the same thing over here for example number 13. You kind of go through it. We left off on class, and I think some people got stuck on this problem over here. So what we're going to do is I'm going to have you do it down over here. So you could just write this problem, and then when you're checking your work, make sure that it's written down, right? So I have 7xyz plus 35yz minus 14xz minus 70z. So the first thing you always want to do is take out the GCF. If there is one, and there happens to be one here, and we saw in class it was 7z, right? Why? Because this is 7 times x times y times z plus 7 times 5 times y times z minus 7 times 2 times x times z minus 7 times 10 times z. We can see they all have a 7, and they all have, not an x, a z. So, what do you take out? You take out the 7z. What's left inside? I have xy over here plus, what do I have? Oh, this is a z here, right? Excuse me. So it's 7 and the z, that's gone, sorry. So I should have 5y, right? Minus, I have here 2xz, right? 2x. Oh, because the z is gone, because I took that out. Okay. And then finally, minus 10. So if you notice, the first thing you do is you take that out and you say, okay, am I done? Remember, you have four terms. So that means you need to try factoring by grouping. Notice over here, these have a y in common. And these here, they have something else as well. They actually have a negative 2 in common. So what we do then is we factor those. So we should get 7z times, I'm going to take out from this guy, they have the y, I'm going to take that out, I'm going to get x plus 5. In here, they used to have a negative 2, so I'm going to get out x plus 5 again. Now we're back to where we were. Now this becomes 7z times y minus 2 times x plus 5. And this is the complete factorization of this problem here. Okay? And that's essentially what the idea is over here. So you should go ahead and try and complete these steps over here. If you want to leave them down there, that's fine. You can go ahead and write them in. Okay? Note, factoring by grouping does not always work. Example 14 goes over that. Okay? But it's most of the time, 90% of the time, that's what's going to be happening. On the next page, page number 21, we're looking at factoring trinomials in the form x squared plus bx plus c, right? So what does that really mean? So if we remember with our tiles here, so remember our factoring, so our goal is to find out what it multiplies to, right? And so we proceed from here. So with this example here, this is our polynomial, and we know it factors to these two terms. So what is these b values and c values in here, right? Well, it's actually, see, this is referencing up here, right, where you have b, c, and then s and t here. So for example, b is the number that is in front of the x, so that's 5. C is the 6. S is this number here, so it's going to be 2, and t is 3. And if we build this with our tiles, you should get the following. Right? That's 1x squared, and then what do I have? I have 5x's, right? And then I have 6 little pieces here. And as we can see, that fits nicely. And I get x plus 3, and here's x plus 2. Notice that it's a whole rectangle here. And this is kind of the main idea behind this. And there's a fundamental relationship here. As you can see, B is made when I add S and T, right? So S plus T is B. And then what is 2 times 3 is 6, so C is just S times T here. Okay. Moving on over here to example number 17 on page 22. I have the same thing. We fill in the values for B, C, S, and T. So B is 1, C is negative 6, S is negative 2, and T is 3. So if we were to sketch this in, what would this look like? I have, there's my big one, and then I have what? I don't know, there's all kinds. So I have one of these guys here, but the problem is now I have some minuses. Okay? So how do I do this? How do I solve this? There's nothing really to be done. Or is there? Well, we can always add a zero pair. Let's do that. I'm going to add in a zero pair because I feel like it. So I'm going to add in a negative and a positive. Okay? Does this help me? Well, maybe. Notice, I have 6 negatives. That means now I can fit in 2 of them, right? Right? And that's better, but I want more. So I can fit in 2 of those. I still have 4 more to fit. I'm going to add in another zero pair. And now I can fit in all 6. And this gives me an idea of what I have. So on top we have X and 1, 2, 3. And this here is X and then 1, 2. Note this is going to be negative because a negative times a positive is a negative, and everything else should line up okay. And so this tells us this is X plus 3, and this is X minus 2. Okay. So this is, and you can see here, sometimes building it with tiles isn't always very totally obvious here, but we get the idea. All right. So again, the relationship between B, S, and T is B is equal to S plus T, and then B is S times T. Why? Because what is negative 2 plus 3? That's 1. Negative 2 times 3 is negative 6. Okay? So, at the top of the page over here, we're getting to just kind of describe the entire thing. If a polynomial can be factored into this, then what's true about B and C, right? So then B is S plus T, and again, C is S times T. So in the same sense, we continue to factor, right? And so when you're doing these over here, when you're factoring these polynomials, what you're really looking for is you're factoring these and you're trying to think, well, what? It's going to be X plus something, right? So you need something that adds to adds to 6 and multiplies to 5 here, okay? So what's that going to be? Well, we have options, right? So you always start with the multiplication. 5 is 5 times 1, right? Or 1 times 5. And 1 plus 5 is 6. So it happens to turn out, right? If I were to build this out, what does that look like? There's one of these. I have 6 of these guys here, right? Okay, and there's 6 of them. What if I do this? There's 6, okay? So now what? Well, oh no, we have a problem, huh? What's the problem that we have here? Oh, I know. Here, I built this wrong. This should be, there we go. That'll work. See, because I have these 5, little ones are going to go here. All right? Ignore that. And then this is 1, and that's x, and this is x. 1, 2, 3, 4, 5. X plus 5. This is x plus 1. And so our answer is x plus 1 times x plus 5 here. Okay? This is a 5. And so we want to just keep this in mind here when we're doing these. Okay? Just to make note, this trinomial does have 3 terms. Okay? So when it has 3, sometimes they can be broken up into a product of binomials. Moving onwards. If you don't have tiles available, what do? Well, you have to kind of guess and check, right? This is what I did basically on the other page, right? 1 times 5 is 5, negative 1 times negative 5 is 5. 1 plus 5 plus 1 is 6, negative 5 plus negative 1 is negative 6. So this was the one that worked. So on the other page, I actually forgot the negative case, right? So I also should have added in and 1 minus negative 1 and negative 5 also multiply to 5. All right. And this is basically reiterating what we've talked about. On page number 25, we're going to factor this guy, okay? So we're going to factor, which means we want to figure out what 2 things multiply to make this trinomial here. And so what would I do? Well, let's build it out here. So what are factors? Well, before we build it, let's try and factor it out using the other method that we just talked about. We'll make a list of these here. So what do we have? So what are the things that we know that multiply to 8, or actually negative 8, right? We have our S and our T over here. We're like, okay, so what multiplies? Well, I know negative 1 times 8, right? Negative 8 times 1, that works. 4 times negative 2, and also negative 4 times 2, right? All of these work, and when we add them up, they must give me negative 2, right? They have to multiply, and here they have to add, right? So, what do? Well, which one works? You figure it out? It's just going to be this one, right? So that means it's going to be x minus 4, x plus 2. So if we were to build this out, let's verify this here. So if I build this out, the tiles, there's x squared. I have minus 2 x's. You can see I have 8 little pieces, and they can't really fit here. So I'm going to add in a 0 pair. Okay. And now I can fit in 1, 2, 3 of the 5, right? Right, because I had 8 of them. I put 3 here. I still have 5. So I'm going to add in another 0 pair. Maybe that'll help. And lo and behold, there's 4, right? 5, 6, 7, 8. I have what I need. And I have my answer. It's x, 1, 2, 3, 4, minus 4. And here, it's x plus 2. Plus 2. And so now we have figured out our answer. It's going to be x minus 4 times x plus 2 over here.